All right, let us see example number 24 from the book. Okay, it is little upper level, little complicated problem. Excuse me. So here you have x to the cubed and then e times e to the x squared divided by x squared plus 1 square, right? So so what I want to do here first is I want to use substitution and change it to little easier format. Okay, so let's say u equals to, let's say x squared plus 1 equals to u. Okay, then what do you get? So it is 2x dx will be what? Du. So x dx will be du over 2, right? So this integral, let me denote this by I. Okay, so you can write I is equals to, so that can be written as like x squared e to the x squared divided by x squared plus 1 to the square times, you can write x times dx, right? Because I want to write because I want to write in that format. So how about if you plug in that x squared plus 1 equals to u, what will be x squared then? X squared will be what? U minus 1, right? From here. So let us do that and then plug back. Okay, so what do you get? Therefore, this is equals to u minus 1. There is still integral times e to the u minus 1 divided by u square times 1/2 du, because this x times dx is 1/2 du there, right? Let me pull that 1/2 outside, 1/2, and then basically you get u minus 1 times e to the u minus 1 divide by, or you can move that to the top and write u to the negative 2, no problem. Okay, no problem with that, du. So this is a little bit complicated, right? So I'm going to do this problem. So what I want to do is I want to take this thing as u and this thing as v. Why did I do that? Because if I take this as v, okay, if I take this as v, then the entire derivative will go up like u to the negative 1 and then 1 like that. You see that? U to the 0 like that. That's why I'm just taking that. So it didn't follow that rule ILATE here, because there are product of 3 things. Okay, so I'm doing the product of these two as u and then that as v. So since they are a product of 3 different functions, so I cannot use that ILATE there. That does not work really. Okay, so so let us do that. So what is the formula for the product rule? Again, let me write on the formula somewhere here. So integral of f times g dx will be f and then integral of g dx minus integral of derivative of f times integral of g dx and then big dx outside. So instead of u and v, I just did f and g, no problem, right? So the reason why I'm doing that is there is u already. You can take u and then write like uv formula, right? U times v dx equals to u integral of v dx, right? Minus integral of u prime times integral of v dx and then outside dx. Either way, right? It's the same formula there. So which is equals to 1/2. Let me write on bracket there. So u is that thing, u minus 1 e to the u minus 1 times integral of v. What is the integral of u to the negative 2? It is u to the negative 2 plus 1 over negative 2 plus 1. That is negative 1 over u. That's what you get, right? Because you get u to the negative 2 plus 1, right? This is what it looks like. So the integral of that will be u to the negative 2 plus 1 over negative 2 plus 1. That will be u to the negative 1 over negative 1, right? So if you move that, you will get negative 1 over u. That's what you get. Okay, guys? So, and then minus the second term there. Minus, so that is minus derivative of u inside the integral sign, derivative of u. What is the derivative of u? You need to use the product rule here, right? This is like, to find out the derivative of u, you need to use the product rule here. So with respect to u, because we don't have any, we no longer has dx, so we are finding the derivative of u with respect to u. Derivative of this guy, u is that guy. Basically it is like f, right? This is function fx, fu. So the derivative of that is, the derivative of the first function is 1 times the second function plus the first function times the derivative of second function is e to the u minus 1 itself. That is the derivative of u times the entire derivative of v is negative 1 over u again, and then there is du. Okay, and then there is a bracket. This is a little bit tricky, right? Because it has 3 terms. 1/2. What do you get here? You get u minus 1 times e to the u minus 1 over negative u. I'm just right. You can plot that, put that negative sign on the top, no problem. Okay, you can put that thing, that negative sign right here, no problem. Minus integral. Let us see what is happening here. E to the u minus 1 times 1 is e to the u minus 1 plus u times e to the u minus 1 minus 1 times e to the u minus 1. Basically this guy will cancel with that guy. So what is left is u times e to the u minus 1. You see that? That's what you get, the derivative of the first function. The derivative of that is, it look like u times e to the u minus 1. Alright guys. So times 1 over u, and again as you cancel, you remember that you cancel this one with the 1, because when you distribute this to u and negative 1, that will cancel out. Now you cancel out this with that one, but there is a negative sign though. There is a negative sign. Okay, there is a negative sign, and then there is du outside. Alright, so what do you get is 1/2 negative u minus 1 e to the u minus 1 over u plus, because negative times negative is positive, integral of e to the u minus 1 and then du. You see that? So how do you find out the integral of e to the u minus 1? That's not bad, because what you can do there is, there is 1/2 at, oh, by the way, I need to close that bracket there. Okay, if I close that bracket, what do I get there then? I get, see that? So it will be equals to 1/2 negative u minus 1 e to the u minus 1 divided by u plus. So you can write like this, right? You can write basically integral e to the u times e to the negative 1 du, and then this e to the negative 1 is a constant. You can pull that out, right? So basically you can write that as 1/2 and then negative u minus 1 over u times e to the u minus 1, and then plus e to the negative 1 integral of e to the u du. So the integral of e to the u is e to the u itself. So you get 1/2 negative u minus 1 over u e to the u minus 1 plus, you get e to the u minus 1, and then plus c is still there, because this is integral of e to the u is e to the u itself, right? And then e to the u and then times e to the negative 1 can be written as e to the u minus 1. Does that make sense? Alright, so let me further simplify again. So 1/2 is there. I want to split that u over u like this. So it is like negative u over u plus 1 over u, and then e to the u minus 1 minus 1, okay, and then plus e to the u minus 1. What do you think? Can we cancel something there? I think so, because this is 1. This becomes 1, right? So 1 times e to the u minus 1, that is negative 1 times e to the u minus 1. And there is a positive e to the u minus 1. That will cancel out too. So that whole thing and that when you distribute that whole thing will cancel out. So what is left there then? What is left is 1/2, and then you can write times 1 over u e to the u minus 1 plus c. That's what it is left, right? What is u though? What is u? Your u is x squared plus 1, right? So so u minus 1 is x squared, u is x squared plus 1. You can write 1 over 2, okay? And then e to the x squared, because u minus 1 is x squared, right? And divide by u is x squared plus 1. You see that? U is x squared plus 1, and then plus c. That is the final answer. So this problem was a little bit, you know, different from the other problems that we did. It has a little bit more work there. Okay, guys. So the next question I want to do is question number 26. Okay, you want to find out the integral of 2x over under the root 1 minus 6x dx. Okay, so on this one we will use, because if there was like 6x squared, we would do that as u, and then you will get 2x dx equals du and so on. But they have the same numerator and denominator. There may be other methods to do, but the easier method will be like this. Let me move that to the top and write like this: integral 2x times 1 minus 6x to the negative 1/2 dx. Do you agree with that? This is root means 1 minus 6x to the positive 1/2, right? And if you move that to the top, it will be negative 1/2. So I want to use substitution, integration by parts. What should be u, what should be v, you think? So it is u, right? It is u, this is v. Why do I know this is u? Because when I use the table, then the derivative of this will go to 0. That is the reason. So the table method will work on this. Okay? So but you need to know what is the integral of that. Do you guys know this formula? The formula that integral of ax plus b to the n. I mean, you can do u substitution and find out the formula, but this one is ax plus b to the n plus 1 divided by a times n plus 1. That's how it works, plus c. Why do I need that? Because we need to find out the integral of that. That's why it is like ax plus b to the n. It's like that. That's why. Okay, guys. All right. Let me make the table there. The table will be like u, and then v. U will be 2x. V will be 1 minus 6x to the negative 1/2. Let's find out the derivative of u. It is 2 and then 0 next time. What is the integral of 1 minus 6x to the negative 1/2? It is like a is negative 6, x is x, b is positive 1, n is negative 1/2. So how do I write that? I will write 1 minus 6x to the n plus 1 will be positive 1/2 divided by a is negative 6 times positive 1/2. N plus 1, because n is negative 1/2. So n plus 1 will be positive 1/2. That's what I'm doing. Okay, now, so what is the entire, so this will be 3, right? If you cancel that out, that will be negative 3, right? Negative 3. That's what you get in the denominator for that part. So we need to find out the integral again, because see, we need to do derivative twice. First derivative will be 2, second time it will get 0. Now here also I found the first integral first time, and then I will do the again. Okay, so what do I get? What is the integral of that again? It's similar to that, right? So integral of 1 minus 6x to the 1/2 will be how much? 1 minus 6x to the, let me use the same color there, 1 minus 6x to the x to the 1/2 plus 1, because now it is n, right? So this is the 3/2 divided by, there is negative 3 already, times, so it is a is negative 6 times n plus 1 is 3/2. That's what you got, right? So what is that total thing here? It is, you see that? That looks like it is negative 3 again if you divide. So it is negative 27, right? So in the denominator you got negative 27. So what is the, let me do the product. This is the positive multiplication, this is the negative multiplication, right? So what do you get then? Then you get, let me write down that the question is integral of 2x over 1 minus 6x. Since it terminated to 0, then we can write the answer like 2x times 1 minus 6x root. That's the root 1 minus 6x, right? And divide by negative 3. You see that? And then this is, you see that negative 3 times negative 3 is positive. So 27 is there, but there is a negative. So it will be, oh, by the way, that is a line, okay? And then I can write minus, it is 2 over 27. You see that? 2 over 27. Why? Because 2 times that, right? 2 times the whole thing. And then you can write 1 minus 6x to the 3/2. You can write that way. Okay? So if you want to factor out, you can factor out 2 over 3 and then write the other things. That is perfectly fine. Okay? If you factor out root under 1 minus 6x. Because do you know what that means? That means, let me show you just. But if you enter this in your online homework, if there is this type of, I think it will accept. But if it does not, then you can try like 2x times root under 1 minus 6x divided by negative 3 minus 2. You can write like 1 minus, the exponent 3/2 is 1 plus 1/2, right? You can write like root under 1 minus 6x times 1 minus 6x. You see that? This is root under 1 minus 6x is 1 minus 6x to the 1/2. That is, and then times 1 minus 6x to the 1 will be like that. And then there is 27. The reason is this. You guys know that x to the 3/2 is equals to x times x to the 1/2. That is same as x times root x. You can write like that, right? That's what I was doing here. Okay? So if you simplify that, what do you get? You get, let me take 2 over 3 out. 2 over 3 and then 1 minus 6x out. So what do you get? You get x, right? So negative x, because I'm taking 2 over 3 and then what is left is a negative 1 left on the denominator. So that is negative x. And then minus, I took 2 over 3. So what is left is 1 over 9 left, and then times 1 minus 6x left. There is a plus, see, I forgot to write down that. So it is 2 over 3 root under 1 minus 6x. And let's see that. Let's make the same denominator. You get negative 9x minus 1 minus 6x divided by 9. You see that? Plus c. That's what you get. So if you simplify, what you get in the numerator there is negative 9x minus 1 plus 6x will be negative 3x, right? So everything, and then here it will be negative 1 minus 3x over 9. Okay, so I didn't have space. Let me write down here. So the final answer look like 2/3 1 minus 6x and then negative 1 minus 3x over 9 plus c. You can write that way. Okay guys, that is the final answer.